EtherChannel can load balance traffic across the physical interfaces that are part of the EtherChannel bundle. However, it's important to realize that the load balancing may not be perfect. What do I mean by may not be perfect? Well, the traffic will typically not be perfectly evenly distributed amongst all of the physical links within the EtherChannel bundle because of the hashing algorithm that is being utilized. This hashing algorithm that's being utilized is going to rely on a hash input code. And what is the hash input code? Well, it's relatively simple. It can be a destination IP, destination MAC address, a combination of a source and destination IP or a source and destination MAC address. It can also be maybe just a source IP by itself or a source MAC by itself. If we get into higher end Catalyst switches like the 45 and the 6500 series, then we can also have source port, destination port, and source and destination port as a hash input code. But regardless of what is being utilized, what is the ultimate goal? The ultimate goal is to determine, based on the hash input code, a value. And in that value will be compared to an index number that's configured on an interface. For example, gigabit 0/23 is given an index number of 0, and gigabit 0/24 is given an index number of 1. So this happens automatically when the EtherChannel bundle is formed. Now, based on the hash input code, let's just use destination IP address right now as our example. This destination IP address is analyzed in binary. And the very last binary bit in the destination IP address is going to be determined based on this hashing algorithm. And if it happens to end in a 0, the traffic will be forwarded over gigabit 0/23. If it ends in 1, the traffic's going to be forwarded over gigabit 0/24. It's that simple. Same thing with the destination MAC. If it's based on destination MAC address, your hash input code that's being used for the hashing algorithm, then the MAC address is going to be converted to binary. The very last binary value is going to be compared. If it's a 0, forward the frame over gigabit 0/23. If it's a 1, forward the frame over gigabit 0/24. What if we have more links, though, in the EtherChannel bundle? For example, what if we had link gigabit 0/22? 0/22. What if we also had 0/25? All right, so now there's 4 links. What type of index numbers might we have in this case? Well, 0, 0, 0, 1, 1, 0, 1, 1. So how many binary values are we dealing with now? 2 instead of just 1. So when we're looking at the destination IP address in this example now, the final 2 binary bits are going to be examined. If they end in 0, 0, use gigabit 22. If they end in 1, 0, use gigabit 24. If we're looking at the source MAC address, look at the final 2 binary digits in the source MAC address. If it ends in 0, 0, use gigabit 22. So what does that mean if we have 8 links? How many binary digits are going to be reviewed if we have 8 links in total? Hope you said 3. Hope you said 3. Because with 3 links, or with 8 links, pardon me, we'll be dealing with 3 binary digits, because 3 binary digits, if you take 2 to the power of 3, you have 8 possible combinations, because 2 to the power of 3 is 8. So your index numbers would be, for example, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, and so on and so forth. Eventually ending up at 1, 1, 1. And then in that case, you'd be analyzing the final 3 binary digits when determining which link to utilize to forward the traffic. But what about these cases here? When we are doing a combination of source and destination IP, or source and destination MAC. Well, this is where the XOR operation comes into play, because we have to compare 2 values now. So here we're looking at gigabit 0/23 and 24 that are part of an EtherChannel bundle. So therefore, we're only reviewing the very last binary digit in the IP address or the MAC address, because we only have 2 links inside the EtherChannel bundle. So the IPs in binary, they've been converted to us, and you can see here in the first example, they both end in 0. So we run those zeros through the XOR operation. 0 XOR 0 results in what? 0. So therefore, it's this value that's looked at, the XOR result that's looked at, to determine which link will be utilized. And in this case, it's the link with the index number of 0, which is going to be 0/23. So traffic sourced from this IP going to this destination IP will use 0/23. What about the next option? Traffic sourced from 1.20 going to 1.21. Well, the source ends in 0. The destination ends in 1, resulting in an XOR of 1. So therefore, link 0/24 is used. So the XOR operation is going to come into play when we are dealing with source and destination as the hash input for source and destination IP or source and destination MAC.